And now I would like to discuss some important terminology that we will be using during this semester, and that I want you to be familiar with. Otherwise, you will struggle with understanding me and passing this course. So first of all, in econometrics, we deal with regression, which is the main tool of econometrics. When I say let's run a regression, that means that I would like us to estimate an econometric model. Regression is a part of regression analysis. You can see a very big definition in front of you, but to put it in simple words, regression analysis is concerned with the study of how one variable depends on one or more other variables. And we're interested in this dependence because we would like to use this information to estimate or predict the value of the dependent variable, of the y variable, the one that we have before the equality sign. Having said this, I would like you to have a look at these terms. So in econometrics, there are, let's say, two main types of variables: dependent variable and independent variable. So the dependent variable, this is the so-called y variable. This is the variable that we have on the left side before the equality sign. And another important type of variable is an independent variable, and or so-called x variable, which we always have on the right side and after the equality sign. They have some synonyms. For example, instead of saying a dependent variable, we can say that it is explained variable, or predictant, or regressant, endogenous, or controlled variable. I think some of you might still remember the term endogenous. We use it during economic analysis. So this is the variable that is estimated within the model. In other words, it is the variable that is explained by the model. And on the right side, we have independent variables, or we can also call them explanatory variables, predictors, regressors, exogenous, and control variables. Once again, I believe that exogenous is a very familiar term to you, and it means that the value of the variable comes from the outside of the model. So I would like you to remember some of them. Most importantly, please remember dependent, independent variable. I will be using this a lot: explained, explanatory, regressant, and regressor. There are some other terms that you should also be aware of. So when we have one dependent variable and one independent variable, that means that we are conducting a two-variable regression analysis. However, if the number of independent variables increases from 1 to 2 or more, this is the case of multiple regression analysis. This is the only difference between these two. So if we have one independent variable, one x variable, this is a two-variable regression analysis. And when we have two or more independent variables, that means that we have multiple regression analysis. And there is a general term in econometrics, random variable or stochastic variable. And according to the definition, this is a variable that can take on any set of values, positive or negative, with a given probability. We will use this term quite a lot, and for now I don't want to focus too much on it, because we will revise the probability theory within the next few classes, and we will come back to random variable a lot of times. So for now, let's keep it this way. This is the variable that can take any set of values, positive or negative, with a given probability. When you study econometrics, another thing that you need to understand is the difference between statistical and deterministic relationships. And the reason for that, because in econometrics, we deal only with statistical relationships, which means that we deal with random variables. And an example of a random variable would be, for example, crop yield and its dependence on temperature, rainfall, tension, and fertilizer. Even though logically we understand that crop yield is very much dependent on these factors, we are not there is no universal way it is dependent on them. In one country, it might be very much dependent on temperature, and when we move to another location, it will be more dependent on rainfall, and so on and so forth. So dependent on the location, the season, and so on and so forth, the dependence and the crop yield itself will be different, which means that it's kind of random, right? There is no universal value of crop yield given this temperature, this rainfall, and this shine and fruit, and this much of fertilizer, because there are other factors that also affect crop yield, which, due to some limitations, physical limitations, I would say, we are not able to account for. The same with Keynesian consumption theory that we discussed before. Even though we know that consumption does depend on income, there is no universal way it depends on it, right? We know that the coefficient should be between 0 and 1, but in different countries, this coefficient will be different. So this is where this randomness comes from. There is no universal value that defines the dependence between the variables, because there are other factors in different, let's say, locations that might affect this relationship. And a deterministic relationship, it's quite easy. This is when we deal with non-random variables. An example, a very good example of such a deterministic relationship would be any law of physics. For example, Newton's law of gravity. This law is universal, no matter where we are, in Africa or in Asia or in Warsaw or in Washington D.C. The law is always the same. So it is not affected by any other factors, except for the variables that are part of its equation. And finally, we also need to know the difference between regression analysis and correlation analysis. So correlation analysis is a very simple type of analysis. It just measures the strength of a linear association. We discussed it during the class of statistics. We estimated correlation coefficients, and we even had a table. You should remember that the correlation coefficient always lies from -1 to +1. So the closer it is to 1, the more positively related those two variables. The more negative the coefficient is, the more negatively dependent they are on each other. And an example could be the correlation between scores on statistics and mathematics exams. Usually, logically, we would expect a positive relationship, but quite strong, because if a person is good at mathematics, he or she should be good at statistics, and vice versa. If a person is good at statistics, we would expect this person to be good at mathematics as well. Regression analysis, on the other hand, is much more advanced, because it allows us to estimate and predict the value of one variable on the basis of the values of other variables. For example, we can have, knowing the student scores on the mathematics exam and knowing the model parameters, we might be able to predict the average score on statistics exam. So as you can see, regression analysis gives us much more information than correlation analysis. That's why we will focus on it a lot. But we'll also come back to the correlation analysis during the course of this semester.